Hi, my name's Oliver, and I'm an applications engineer here at Maxim. Do you want to learn how to design a power supply in 5 minutes or less? Well, you've come to the right place. There are 4 key requirements that you need to figure out before you design your power supply. They're input voltage, input current, output voltage, and output current. For my design, I want to step 12 volts down to 5 volts with a 5 amp output. Fortunately, Maxim has a great online tool for designing your own power supply, and it's called EESIM. It's available right on our homepage. Let's check it out. To get to our homepage, go to www.maximintegrated.com. Once you get there, go to the left nav and click Design, then Design Tools. Under the EESIM heading, click Design and Simulation Tools online. Then click Start the EESIM tool. Because we're designing a power supply, we're going to select DC to DC converters. On this page, you can input your initial specs for your converter. For ours, we want our minimum input voltage to be 9, our maximum will be 40, and our nominal will be 12. We want 5 volts out at 5 amps. Now we don't need a second output. Step-down switcher is automatically checked for us, and we're going to leave the features unchecked for now. EESIM picked 2 different converters to choose from, the MAX17506 or the 17546. I'm going to choose the 17506 because it's a little bit cheaper. This page allows you to enter some more details about your converter, like input undervoltage lockout and input ripple voltage. For the most part, I like what I see so far. For performance, we're balancing efficiency and size, and we're going to prioritize cost in our BOM. The one thing I will change is switching frequency. Let's bump it up to 450 kilohertz. From there, click Create Design. Once your design is created, you'll arrive at a page that looks like this. You can see that EESIM created a full schematic, including peripheral components, of the MAX17506. I'm going to run some simulations on this by clicking on the Simulation tab. I think I want to run steady state and efficiency measurements. So I'm going to select those on the side, and I'm going to deselect the AC loop measurement. Just to verify, for steady state, my input voltage is going to be 12 with a 1 milliohm series resistance and 5 amps of load current. For efficiency, I'm getting 500 data points with an input voltage of 12, 1 milliohm series resistance, and a start current and stop current of half an amp and 5 amps respectively. Now I'm going to click Run Simulations. Once the simulations are finished, they'll appear on the right side of your screen. Let's take a look at the steady state waveforms. We have 4 different waveform tabs. Waveforms from the IC itself, the output, the switching node, and the input. As you can see on the switching waveforms, we have our classic buck converter inductor current waveform and the voltage waveform overlaid on top of each other. And you can customize this down here. Let's take a look at our efficiency measurements. You can see for the most part it's pretty good, above 90% almost across the entire output current range. At 5 amps we get just below 92.5%, and our best efficiency occurs around 2 amps, and that's just above 94%, so that's pretty good. So that's just a quick tour of EESIM and all of its capabilities. One last thing, if you want to download your design, that's schematic, BOM, all of your input and output parameters, you can go over to the Report tab and do that there. Now if you're thinking what I'm thinking, the EESIM tool is pretty slick. I was able to design a power supply and simulate it in a number of minutes. But how reliable are those simulations? Well, I have the MAX17506 EV kit right in front of me. It's configured for 12 volts in, 5 volts out, 5 amps out with a 450 kilohertz switching frequency, exactly how our simulation was configured. Let's take some efficiency measurements and see how the hardware and the simulations compare. All right, we've taken some efficiency measurements. Let's see how they compare. I've overlaid the efficiency curves of the MAX17506 EV Kit and the EESIM simulations. The EV Kit data is in blue and the EESIM simulations are in yellow. As you can see, the EV Kit actually outperforms the EESIM simulations just by a little bit. I've also put the efficiency equation here for your reference. If you remember at the beginning of this video, I mentioned that your input current is a key parameter when you design your power supply. Now what I mean by that is that your input source has to be able to supply whatever your input current is in order for your power supply to function properly. In order to find out what your input current is, we're going to back calculate using the efficiency equation. Assuming a 90% efficiency for this converter, with 5 volts out, 5 amps out, and 12 volts in, we can calculate that our input current is going to be about 2.315 amps. So as long as our input source can supply that or above, our power supply is going to function properly. That's all I have for now. If you want to design your own power supply in 5 minutes or less, be sure to check out Maxim's online EESIM tool. Again, my name's Oliver. Have a great day.